Okay, so I'm supposed to talk about the sine and the cosine curve to help us with the values of the sine, cosine, tangent of 0, 90, 180, 270, 360. I know we did look at it. If you can remember that in the unit circle, any point, the radius is always 1 in the unit circle. And any point that you are going to find on that circumference of the circle is going to be the cosine and the sine value. So the x value of that coordinate point is the cosine, and the y value is the sine of that. So I think one question that we had was, what was the sine of 180 degrees? And the sine of 180 degrees, find 180 degrees. Sine is the y value of that coordinate point. That coordinate point is -1, 0. So the sine of 180 is 0 degrees. The other way you can look at it is if you were to take that sine curve and put it into a linear format of all those coordinate points that you were laying out at 180 degrees, here's what we do. Sine and cosine range from -1 to 1. And then you can look at your quadrants. So you have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So this also helps you. So right here is 90 degrees. Sorry, just a minute. There's 180. Here's 270. And here's 360. This also helps you tell you what quadrants they're positive in. So if you look at, it's just another way to help you memorize some of this stuff. You have all students take calculus. So if you look at where sine is positive, it's positive in the first and the second quadrant. Well, all your values are above 0 here. And in this third and the fourth quadrant, they are below 0, which over here it tells us sine is positive in the first and the second quadrant. So it's just another way of looking at it. Did you have those curves on your unit circle paper or not? I tend to think of the curve mentally a lot when I'm trying to figure out which quadrants is it positive, which quadrants is it negative in. And in the unit circle, it makes sense because sine is your y values and y is positive, anything above, which is in your first and second quadrants. But it can also help you if we talk about that curve. I'll wait till you copy it down and I'll draw the cosine one up here. I should do it on another screen, but we'll do it here. And then you can also, oh, and I forgot to record this. Gosh, dang it. And you can also look at the cosine curve. Oh, I am recording it. Never mind. I thought I forgot. Okay, so here's what we need to look at as we go through it. The unit circle, I put in red the values of 0, 90, 180, and, or 270 and then back to 360. But if you look at your sine curve, and this is where if you just get the visual of it, it tells you it's positive in the first and the second and negative in the third and the fourth because it's below 0. But here's something you can do. At 0 degrees, what's the value of sine? 0. At 90, 1. At 180, 0. At 270, -1. And at 360, you're back to 0. So if you can just think of that curve, its peak or its 1 is at 90, and it's -1 at 270, and it's 0 at the other 3 values. Now you get that from over here in your unit circle. If you look at your unit circle, we said it's because sine, so you're looking at the y values, you're 0, 1, 0, -1, and back to 0. See the connection? Then if you look at the cosine curve, we're looking at the x values in the unit circle, right? But if I think of this graph, looking at that graph, the cosine graph, if we look at the cosine graph, where is cosine positive at? First and fourth quadrants, because that's where it's above 0. It's negative in the second and third quadrant, because that's where it drops down below. Now, if you look at your values, what is the cosine of 0 degrees? 1. Well, that agrees with the unit circle. What's the cosine of 90 degrees? 0. What's the cosine of 180 degrees? -1. What's the cosine of 270? 0. Of 360? 1. So I don't care which one you use, but the sine and the cosine curve can help you. Now, as far as tangent goes, tangent gets to be kind of a weird looking graph. It's sine divided by cosine. So if you look at 0 degrees, it's going to be sine, which is 0, divided by 1, which is 0. You're going to get a graph that looks like this. And it's going to keep repeating itself. But if you look at 90 degrees, so if I let this be 90 right here, something happens. It's sine, which is 1, divided by cosine, which is 0. What's that? Undefined. So we actually get a vertical asymptote right here, something that's going to approach but never cross. So then we look at, after 90, we're going to have 180, which would be right there. 180, the sine of 180 is 0, and you divide by -1, which is 0. You're going to get this curve going on again. Then what's going to happen at 270? You're going to get a vertical asymptote again. Because at 270, you're going to have -1 divided by 0. And it can't happen. You look at quadrants in which it's positive in. So you've got to get some values here. Here's 90, 180. Here's 270. And it's going to repeat again. But you look at your quadrants. In the first quadrant, what do you know about tangent? It's positive. In the second quadrant, what do you know about it? It's negative. All students take calculus. It's negative here. In the third quadrant, which is from 180 to 270, what is it? Positive. Well, that's what it is in your graph here. And then, of course, if I were to repeat that curve over here, it would drop down right there. So in the third quadrant, or the fourth quadrant, it is negative. So a connection between unit circle and the actual graphs of them. Now there's things that change when you talk about the inverse of them, and then you can get into sinusoids, which is shifting them, and hopefully by the end of the year you'll remind me to go over some of that stuff, because I know that Grant saw it in calculus, and I know that it's probably in college algebra. Which all it does is if you change this, it's translations of it. If I change the center line, if I change the amplitude, just like if I put a coefficient to x squared and make it a 3, what does that do to your parabola? Makes it skinny. Well, if I put a value in, what's it going to do? It's going to increase the amplitude of your graph. So we can do different things in an equation to change that. But that's just the typical sine and cosine curve. And the cosine curve is the sine curve. It's just shifted over 90 degrees. It's basically all it is. So when you're writing sinusoid equations, you can write it in terms of sine, or you can write it in terms of cosine that has a translation involved, or vice versa. So lots of different ways. You can take one of them and you can write your answer probably 3 or 4 different ways. That's not any different than when we talk about writing from rectangular into polar format. You have 4 different ways you can write it. So the same kind of exists when you're talking about your sinusoids. So thanks for reminding me that I was supposed to talk about that on Friday or sometime in there, and I did not. Okay, law of sines and law of cosines. First of all, if we remember what we were talking about, is we were talking about adding vectors. And we had vectors head to tail. And this gets into more physics, something you would use in a physics class if you were to take that. And adding the vectors head to tail, we said that if we are going to add them, we could look at just the x components and we could look at the y components. And if I add them together, it's going to give me the resultant x and y component. So we took my 2 vectors, 4 at an angle measure of 20 degrees and 7 at an angle measure of negative 230 degrees, and we converted those into rectangular coordinate system. When we found out the I and the J values, we added those together and we took that answer of negative 0.74 or negative 7400ths I plus 6 and 7300ths J, and we went back and converted that back into polar format and came up with our resultant. So if someone pulls at an angle measure of, or if someone pulls at 4 newtons of force at an angle measure of 20 degrees and someone else at 7 newtons of force at negative 230 degrees, your object's going to move with a force of 6 and 7700ths newtons at an angle measure of 96 and 27 or 96.27 degrees. So that's what's happening with our object. And we drew a picture of it and we found the resultant to be right there. Now I told you there is another way that you could actually add those together, and that's using the law of sines and the law of cosines. And I believe you copied this down on Friday somewhere. You started and then the bell rang and you did not finish. So you want me to shut, I'll pause this. Actually, I might just have to save it. I'm just going to save this.